Hi, Dr. Pat here. We are working on matrices. We're being introduced to them in terms of how you can manipulate these things. They're individual things. We're doing some algebra on there. We're going to have some matrix fun here. Okay, so I've got three matrices here. I got A, B, and C, and they're all three of them are have dimensions of 2 by 3. They have two rows and three columns for each of these three matrices. Okay, so now we're ready to go. Basically, what we want to do is we want to find A plus B, B minus C, 1 half of B, 2A minus B, 2A minus 4C, A minus 4 times the quantity of B plus C, 3C transposed, 2A transposed minus C transposed. So those are the things that we want to find. So this is some of the algebra that we'll be working on. Okay, our first one is A plus B. So what we've got is we've got the A matrix, we've got the B matrix. We want to add these things together. We will add the numbers in the same spots. So what's in the first row, second column, I will add the first row, second column numbers and then put that result there. And so what I get here is this result. So I'm taking the 1 plus the 3 to make that 4, negative 1 plus 0 to make the negative 1, 0 plus the negative 1 for that negative 1, and so on and so on. And then you just kind of repeat the process for that second row. B minus C. I'm going to take the B matrix minus the C matrix. So I'm going to take 3, going to minus 5, 0 minus 6, negative 1 minus 7. 5 minus a negative 2. So that's going to be added together. Negative 1 minus 1. 1 minus a negative 3. And when we do that, we get this matrix here. So just kind of taking those results of each of those positions and putting the results in the appropriate spot. And so that was a 5 minus negative 2 to create a 5 plus 2. That's where that 7's coming from. Now 1 half B. So that's scalar multiplication. We're going to take the B matrix and we're going to multiply it by 1 half. So each piece of there, each element of this matrix, we're going to multiply by 1 half. We'll distribute that idea of the 1 half, and so this is what I get. Just remember 0 times the 1 half becomes 0. Now we have 2a minus b. We're going to do this in a couple of steps here. So what we have is we're going to take 2 times the matrix A minus the B matrix. So my first step I'm going to do is I'm going to take the 2 and multiply it through, just like we would do order of operations, multiplication before we do subtraction. So order of operation, just go ahead and keep thinking that, same type of algebra that we'll be working with. And so then just go ahead and multiply each of the A matrix by 2. And that's what I see here in red. So that's my multiplication. And now I'm ready to subtract the B matrix. And so I'm going to take that 2 minus the 3 and so on and so on. And I get this result. Now we have 2a minus 4c. Same thing, we're going to multiply the A matrix by 2 first. We're going to multiply the C matrix by 4. So when we do that, we're going to have to do that first, and then we'll do the subtraction. So order of operations, so key here. Just go ahead and multiply each of these elements here inside the A matrix by 2. Multiply each of the elements of the C matrix by 4, and then we'll subtract. And so that's what I have. In red here is my result of multiplying the A matrix by 2. And then the result I get when taking the C matrix by 4. Now we're ready to subtract. 2 minus 20, negative 2 minus 24, negative 2 minus negative 12. That's really a positive 12 kind of idea. Each of the elements we're matching up and doing the subtraction. And this is what I get. Now we've got A minus 4 times the quantity of B plus C. Once again, we've got to do this in stages. I'm seeing really 3 stages here. Order of operation says do the stuff inside the parentheses first. So we have to do the B plus C together. Then we'll multiply by 4, and then we'll take the differences of the 2 matrices. So we're going to take B plus C, and that's what I get. So taking the elements of B, matching them up, and adding the appropriate ones, and this is what I get. So there's the result of B plus C. Then we're going to take that and multiply by 4. And so here in blue is the result of taking the previous result and multiplying by 4. Now we've got two matrices ready to go. We can take the differences of those two matrices, and then this is what I get. Now we've got 3 times C transpose. So basically I kind of treat it like my order of operations, powers before multiplication, even though technically I know it's not really a power, but it's kind of like that. And so basically I'm ready to do that first. So I'm going to take the transposition of the C matrix, and that's what I have here. And then we're going to multiply that result by 3. So what I've done here is what used to be a 2 by 3 matrix becomes a 3 by 2 matrix. What was in the second row, third column goes into third row, second column. The row and columns get switched around the positions to create the transposition. And then, just like scalar multiplication, we're going to take that 3 and multiply everybody by 3. And so that's where we get this matrix. So the first thing I did here was transpose and then multiply by 3. But I have to be honest here, you could actually have multiplied by 3 and then transposed. It's one of those things where you can do the orders any way you want. I just kind of like that, keeping it clear or keeping it like order of operations that we have before. So, but in this case, transpose, you can do it either direction. Okay, and so now I've got 2 times A transposed minus C transposed. So I'm just going to transpose each of those matrices, change the rows and columns around, switch the positions of the elements, and then we're going to multiply that 2 to what the result there in that first one, and so that's what we see in red. So I'm just taking 2 times each of those elements. Now that I've got my two matrices ready to go, they've been transposed, I multiplied by 2. Now order of operations says I can do the subtraction, and so then that's what I've got here. And then our final result is this matrix right here. So, just some examples of a little bit of matrix algebra. Hope this worked out. It's actually hopefully not too bad. Just basically remember your order of operations. Just try to do them one step at a time. Don't try and do too much while you begin with this. I know you can kind of combine some steps and really work it that way. When you get comfortable, go ahead and start doing those shortcuts. But until you're comfortable, I recommend just take your time and just do some few steps at a time. Hey, this is Dr. Pat. Hoping you're having a good day.